Hello students, we are going to discuss about the types of operations in PDA. There are four types of operations: push, pop, read and replace. So coming to the first one, push operation. Here we are in PDA we are going to use an input tape and the stack. Stack contains a default symbol Z0. Let us assume some symbols are present in the input tape which we have to pass through the machine. And when we want to pass this through the machine and when we want to read the entire string which is given to us, we have to pass each symbol at a time through the machines across the different states. Okay. So under this push operation, we start with the initial symbol which is present in the stack and we try to first push it on the stack. So already Z0 is the topmost symbol. When we push A onto the Z, A will become the topmost element and Z0 will come down. The next symbol, when we are pushing onto the stack, the second symbol, second A will be the topmost element, remaining two elements will go down. Okay. So likewise we'll continue with the rest of the input symbols. When we have B, B comes on the top of this stack and the elements will go down since it is a stack. And when we have to push or when we have to pop, when to operate or this all this type of operations, that will come to know when we are doing the problems. So coming to the transition diagram, whenever it is asked to design a PDA, they initially ask to write the transition table. Designing a PDA means they are directly asking the transition table. So it is like constructing a house directly. That means we are writing a transition table means we are constructing a house directly without any architect plan. Okay. So first we need to draw the architect plan and then we have to construct the house. So similar way, and so before going for the transition table, we need to have the transition diagram. Based on this only we are going to write the transition table. Okay. So whenever a PDA problem is there, they are asking the transition moves. These are called as transition moves or PDA moves. First we need to write this, then only we have to go for the transition diagram. Okay. So in order to do these things, what we do in the problem is we first leave space for the transition table and then we go for this diagram. After drawing this diagram we get a clear idea about the working of the PDA. Then after getting the diagram, based on these transitions we are going to write the transition table. So first we'll see the transition diagram. So initially we have an input tape symbol A and then we have the Z0, that is the symbol on the stack that we are moving on to the stack. So output is we have to show what is the resultant status of the stack, that is our output. We should not bother about the symbols that are left in the tape. So first here we are pushing onto the stack. Initially Z0 was there, that was a element with topmost element in the stack. When we push it becomes a Z0. Then when we want to push the second A, we are considering this A, that is our next input. Input tape symbol is our next input. Then we are going to consider the topmost element which is present in the stack. The topmost element which is present in the stack was this A. This A, when it was pushed over here, it was removed from the input tape. So this second A will come over this first A and then the output will look like this. The second A will be top of these two elements and then this A will be removed from the input tape. Then next B, if you want to push it on this, so this will be on top of this A. So B will be pushed onto A and it will be removed from the input tape. So we have to show the topmost two elements in the stack. Whenever we do push operation, always we have to show only the two elements which are on the top of the stack. So here A, Z0 was the two elements we have shown. Here three elements are there, we have to show only the topmost two elements. So this is AA. Here when we push B, the status is like this, four elements are there, but you have to show only the topmost two elements, so the status is PA. In this way we can continue until this total input is finished. Once this total input is completed, when we read all the symbols in this input tape, we can go to the final state and we can stop. And how to write the transitions for this? This is a transition table, or we can also call this as transition moves or PDA moves. It is simple to write this one. You have to identify what is the initial state. At this initial state we are, or we can say this is a present state, which through which we are giving these two inputs, and after taking these two inputs it is moving to this state Q1 and it is changing the status of the stack to this two symbols. So that's what we are writing. Delta of Q0 A Z0, that is equal to Q1, and the status of the stack is A Z0. Similarly, if you take the transition between these two states, we can write delta of Q1 comma AA. These are the input tape symbol and stack symbol. It is going towards the Q2 state when these two inputs occur, and then we have AA is the status of the stack. So this is about the push operation. Then second one is pop operation. This is when we want to remove one element on the top of the stack. So these are some symbols we have. Okay, we do normally the pop operation when some condition is given. Let us assume whenever there is an element A found in the input tape, and if for this A, if there is corresponding element C on top of the stack, then we are going to pop these two elements. We have to pop A as well as C. Okay, so when we do this, when we remove A and when we remove C, this cell will be empty, and this empty cell is represented using this epsilon. Then when we remove this C, H will come up to the top position. Then input tape symbols are X, Y and B. Then we have H, E, Z0. This is the status of the stack. And for every X, if there is H which is on top of the stack, immediately remove X as well as H. Okay, so that's what we are doing. X is there, top symbol is H. Remove X and H from input tape as well as stack, and the resultant status of the stack is epsilon. We have to show the status of the stack as our output. We should not bother about the status of the input tape while writing the output. The next one, still if some more symbols are there, you can also pop Y and E simultaneously, and the resultant, this cell will become empty, and epsilon is, this empty cell is represented by using epsilon symbol, and this Z0 will come up whenever, that is whenever a cell is empty, the elements which are below that empty cell will come up one by one towards the top. And this is just an example of transition diagram. You can see here A is there, we are taking C as a corresponding stack symbol, then remove A and C from their input tape as well as the stack symbol. This empty cell is represented by epsilon. Similarly XH and YE. And the same thing, this total transition we are going to represent using this PDA moves or transition moves. Q0 is the initial state, A comma C are our inputs. This is leading to a new state Q1, and the output, the status of the stack when we are doing pop operation is epsilon. Similarly, the remaining symbols. At Q1, XH are the input. When these two inputs are given to Q1, the machine will enter from state Q1 to Q2, and the status of the stack will be epsilon. So likewise we can extend it to remaining symbols.